to find the distance that the dragster went. I was just curious, all right? I was just curious about how far that dragster would go, all right? Is there a third part? Yeah, okay, there's kind of a different. So the dragster, x final, so it's going along, is equal to 0 plus its initial velocity was 0 times the time that we was given was 0.6 seconds is plus that huge acceleration. What is the acceleration of that dragster? 44.7 meters per second squared. 1/2 of 44.7 meters per second squared times the 0.6 seconds. I'm just curious how far it went in that 0.6 seconds. So we got 0.5 times 44.7 times squared. Haha. Times 0.6 squared. 8 meters. Boom! 0 to 60 in 8 meters. Wow. You better get out of the way. 8.05 meters, we'll say. You better get out of the way. That's like 25 feet. That's a rocket, essentially. Okay, so, well, that was fun. All right, now, this next problem's kind of tricky. This next problem's kind of tricky. Let's get this out of the way. It says a car is traveling at 20 meters per second. I think that's 20. Yeah, that's 20 meters per second. And the driver sees, this is problem 33 in your book, if you want to get a better. And the driver sees light turn red after 0.53 seconds, the reaction time. This is a very good problem. Now, this is a starred problem, which means it's a little bit harder. That means it's an engineering type problem. They don't want to scare you little biology and chemistry major. I don't know why. You're smarter than most engineers I know, but anyway, the driver applies the brakes. Okay, so he goes for 20 meters per second for 0.53 seconds before he even starts to deaccelerate. All right, applies the brakes, and the car deaccelerates at 7 meters per second squared. Okay, is that positive or negative? Deaccelerates. Yeah, there you go. What is the stopping distance the car is measured from the point where the driver first sees the red light? Well, we've got two distances. We got the distance going at a constant velocity of 20 meters per second for 0.53 seconds, and then we've got the distance of him stopping. So when he actually applies the brakes and deaccelerates. So here's what's going on. You got the car moving this way. Okay, car's moving along. Boom, 20 meters per second. And for a time interval here of 0.53 seconds, it's going at 20 meters per second the entire time. Then all of a sudden it starts here. So during this time, how far did it go? Well, we know that x is equal to rate times time, 20 times 0.53. So the distance that it traveled would be that 20 times 0.53 seconds. So it went an extra 10 meters, 10.6 meters before he even was able to slam on the brakes. And 20 meters per second is pretty fast, divided by 0.447. If I take that 20, you're going 45 miles an hour. This is why it's so important you drive slow in school zones and stuff, or neighborhoods, because you're going 45, which doesn't feel that fast, but you're not even going to stop for 10 meters. That's 30 feet. Okay? That's like if you're at one driveway and a kid runs out from another one, you're going to hit him if you're going 45 meters because you don't have time to stop. You're going to hit him full speed. Sorry, I didn't mean to get gruesome there, but now, okay, so now we've got an initial velocity. Now we've got to figure out this distance after he applies the brakes. Well, that's not going to be too bad. That's not going to be too bad but here's how you set it up. Okay, so now in the second part, I've got an initial velocity of 20 meters per second. What's my final velocity if I come to a stop? You got it. 0 meters per second. And we want to figure out how far that is. All right. Well, we can. There's ways we can, and we know that the acceleration is 7.0 meters per second squared. All right, I can do this in two ways. I can figure out the time. I'm going to do it the first way. I'm going to figure out the time it took him to come to a stop. All right, and that's negative. So if I've got v final minus v initial over the time is equal to -7, then the time is equal to 0 minus 20 over 7, which would be over -7. So you notice, time is always going to be positive. Of course, he can't be going at 21 meters per second. He's got to be going at 20, but that's okay. It's 2.85 seconds. Let's go with 2.86 seconds. That's how long it took. That's how long it took him to stop. And then you can figure out the distance because you can just go x is equal to x naught, or x final is equal to 0, plus, now hold on, we've got to be careful because we haven't had this before. He had an initial velocity of 20 meters per second. 20 times 2.86, this is v naught times t, minus now, in this case, minus 1/2 of 7 times the 2.86 squared. Okay, that's kind of got sloppy there, but there we go. So we'll just calculate that. So we got 20 times, I'm just going to use my answer from before because that's what it's doing there on my calculator, minus 0.5 times 7 times 2.86 squared, and that's 28 meters. 28.5 meters. So the total stopping distance is these two, plus 10.6. This is kind of a good test problem because it tests a lot of stuff over chapter 2. Just tests everything. 39.1 meters. So the total stopping distance is 39.1 meters. Okay. Now, you might have said, well, wait a minute. I've got a final velocity. I got an initial velocity. I got an acceleration. I just don't have a distance again. I could have used this formula. V final squared is equal to V naught squared minus, in this time, since the acceleration is negative. You see, I've already factored out the 7, the minus 7, 2 times 7. So I don't want to, or 2 times 7 times x final minus 0. Okay. Notice, I could have had plus -7 here, but I just go ahead and factor that out this way. So I've got 0 is equal to 20 squared minus 14 times x final. And boy, do I hope that x final is equal to 400 divided by 14. What I got before? Yes, 28.57 meters. That's for this distance, and then you had to add this distance. Okay, that's enough for that problem. Now we're going to go into free fall.